library. Today we'll be learning about Ernest Rutherford, who could be considered the father of the nuclear atom. More importantly though, he was a superb experimentalist. In Einstein's words, one of the greatest experimental scientists of all time. Ernest was born in New Zealand into a poor farming family in 1871. When young Ern, as his family called him, received his first science book at the age of 10, he was hooked, even though he still had to keep working at his farm chores. After he graduated with his master's degree, he looked for a job as a school teacher, but he could not get a permanent job. The major turning point in his life occurred when he chose Professor J.J. Thomson, known back then as J.J. by his students, at Cambridge University's Cavendish Laboratory as his doctoral supervisor. Cambridge had just instituted the new Doctor of Philosophy degree, and Rutherford was among the first to earn this degree. By 1898, at the age of 27, with JJ's help, Rutherford obtained his first job as professor at McGill University in Montreal, Canada. At McGill, Rutherford made his first great discovery that the atom is composed of parts and that its character can change. One of the atomic parts he discovered and identified was the alpha particle, which in effect is just a helium atom with its electrons stripped off. His discoveries in this field were considered so important that he received the Nobel Prize in Chemistry in 1908 at the age of 37. By then, he had been induced to move to Manchester, England, to accept his second job as head professor of physics. One spring day in March 1909, Ernest Rutherford was sitting at his desk, deep in thought. Rutherford's thoughts were interrupted by a faint knock at the door. Come in!
Professor, this is Ernest Marston, one of our students who is in need of another graduate research project. I have been training him in radioactive methods. Do you think that he might begin a small research project with us?
Hans spoke with a thick German accent, having recently arrived from Germany to take up the John Harling Research Fellowship at Manchester in order to work with Rutherford. I think that it's a good idea, provided that Ernest is willing to work at the arduous task of observing scintillations. Scintillations, sir? What are they? Stammered Ernest. They are tiny flashes of light when alpha particles strikes a fluorescent screen. Of course, you can't see them unless you use a microscope, and your eyes can't detect them unless you first sit in total darkness for at least half an hour with your eyes open. Then you must be prepared to stare into the microscope and hold your eyes open without blinking for at least 2 minutes at a time and count all the flashes you see. It's not easy. So I'm willing to give it a try, replied the young Marsden. Rutherford had a flash of inspiration. Then why don't we have Marsden here look for alphas that are scattering through a large angle? It's never been done before.
Agreed,
said Geiger. Then we will go ahead, replied Rutherford, and Marsden nodded. Rutherford, though, had a sheepish look on his face. What he had not said is that he had not confidence that Marsden would succeed. What if he failed? How would that affect the student's future studies? 3 days later, Rutherford was sitting at his desk and writing as usual, when he was interrupted by a loud knock at the door. Rutherford jumped, his concentration having been lost. "Oh, come in," his loud voice boomed. The door swung open and Geiger strode in, obviously in an excited state.
Professor, we have made the most incredible discovery. Some of the alpha particles are coming backwards towards the source.
For a moment, Rutherford was lost for words. Then he replied, "Hans, explain yourself." Geiger continued.
We have used the radium source to project alpha particles at gold foil mounted on a thin glass plate and find that about 1 in 20,000 of the alpha particles have their directions changed to such an extent that they emerge again at the site of incidents.
Rutherford was stunned. This is incredible! If the atom is indeed like JJ says, then they would be about the equivalent of shooting. It would be like about the equivalent of shooting a 15-inch archery shell against a target of tissue paper and having it bounce back towards the gunner. Geiger laughed.
I hadn't thought of it quite that way.
Rutherford's eyes glazed over as he spoke to himself. This means that we must indeed revise our pictures of the atom. We must indeed revise our picture of the atom. I wonder...
Sir, should we complete the experiment and write it up for publication?
Yes, indeed. Let us do it, and with haste. The next 2 years passed like a whirlwind, with experiment after experiment revealing more detail about the scattering of alpha particles when passing through matter. It was the Sunday before Christmas in 1911, and the Rutherfords had decided to host the Christmas dinner for their friends and colleagues. After supper, Mrs. Rutherford served the traditional Christmas plum pudding. Instead of digging right in, Rutherford just stared at his pudding. Is something the matter, dear? Why don't you eat your pudding? Mrs. Rutherford asked. Rutherford uncharacteristically ignored her question and instead began to speak excitedly. Now I see it! Oh, why, it's JJ's model. It cannot be right. And the atom must be like... what's the atom must be like? It cannot be like this pudding, when the positive charges, like the plums, and the negative charges, like the dough, the positive charge must be concentrated into a small region in the centre, and the negative charge must be concentrated perhaps like a cloud around the centre. The dinner guests were suitably impressed by Rutherford's insight, and an animated conversation took place. The next morning in the laboratory, Rutherford met with Geiger as usual. Triumphantly, Rutherford announced, "Hans, I know what the atom looks like and how we must explain the large scattering of alpha particles. Most of its mass is concentrated near the centre of the positive charge, and the negative charge, in the form of electrons, is much smaller and further away from the centre." Geiger appeared somewhat concerned.
Professor, there is certainly a revolutionary idea, and it will not be viewed too kindly by JJ.
Confidence rang in Rutherford's voice. If JJ had not put forward a theory of his own, he would have to admit that I am right, as the evidence is strongly against him. Rutherford published the details of his new model of the atom, but not too many people believed him at the start. It remained up to Niels Bohr to join Rutherford and devise his Bohr atomic model, which was the refinement of Rutherford's idea and the first model that explained the atom in a way that was consistent with all the known observations. So that is the story of how the nuclear atom was born. But it was not until 2 years later that Rutherford first used the word nucleus to describe the centre of the atom. Toodaloo!